So let's get started. Who am I? Why am I talking in front of you? I am a software engineer at a German startup called Loodse. I work remotely from Mumbai. I'm also active in the upstream Kubernetes community, and I'm on the Kubernetes steering committee as well, and I'm a technical leader of one of the 6. So every Kubernetes story starts with a cluster. So let's say you have a cluster. It has an app which is running in a pod, and you have a secret which contains a password for this app. And one day, you notice something strange, that the password value in the secret got updated, and you did not make this change. Now that looks really scary and looks like something is fishy and something weird is going on here. And since you think something's weird's going on, you decide to look at logs. And let's just assume you don't know about audit logs, because we need that for this presentation to continue. So you decide to look at logs from the pod. It might tell you that the value got updated, but it won't tell you when it happened, or you can figure it out maybe, but it won't really tell you when it happened or who did it, which is the most important thing that you want to find out. Then you decide to look at events. That also doesn't tell you who did it. It might tell you that the secret value got updated, when it got updated, but again, it doesn't tell you who did it. The same goes with API server logs. You still don't find out how this change came along. So you're stuck now. You decide to head back to the Kubernetes website. You search for what you can use, what feature you can use to make this happen. And then you come across this shiny thing called audit logs. Audit logs give you a lot of information about what's going on in your cluster, sometimes way more than you need, and you need to filter out what exactly you're looking for in all of that huge blob of data. So this is what an audit log looks like. It's a huge JSON blob with lots and lots of information. I don't expect you to read that. It's just way too much. We'll be looking into detail about what each of those represents, and we'll try to understand what it's made up of. So the first thing these audit logs tell you is what actually happened. So if you did something like a kubectl get pod or a kubectl create secret. So the verb in this case is get, create, update, delete, list. So it tells you about what happened in the cluster using the verb. In this case, in your cluster, since let's say a secret got created, the verb would be create. On what resource did this action take place? On a resource in Kubernetes is a pod, all Kubernetes API objects, a pod, a secret, a replica set, a deployment. So the object ref key in the whole JSON blob gives you more information about what resource got updated. When did it happen? When did this change happen? So one thing to understand over here, and I'll be going into more detail about this, is that Kubernetes audit logs are basically logs whenever a request hits the API server. So it always happens at the API server. So whenever we talk about when it did happen, there is something so the first thing you see is a request received timestamp. So this is when the request was received at the API server, and you don't need to worry about what stage is right now. We'll go into that a little bit later. Who did it? So this is the most important information that you're looking for. How did this change come along? And that's mentioned in the audit logs. I used Minikube to just get this example going. How many of you all have used Minikube to understand Kubernetes? Quite a few of you. So we have a Minikube maintainer amongst us. I don't know if he's here. Rohit, Anand, yeah, he's here. He's on the first row. So if you all want to know more about Minikube or have questions or want to get involved, find Rohit in this session. Yeah. The next information that it gives is where was this request initiated. So it gives you an IP address for the same. So that's a lot of information that you get. I just want to give a brief one-liner for folks who are just joining in. So Audit logs give a lot of information about what goes on in your cluster, who made a particular change, what change was made, when was this change made, and it also answers all of your what, when, how, where questions. And audit logs are dependent on basically whenever a request hits the API server. So any request, even if like I'm making a call or if the system's making a call, all of these get logged. If I do a kubectl get pod, the system runs I think like 40 or 60 more calls for just one kubectl get pod, and all of these get logged. And you have to find what information you're looking for from this huge blob of data. And that's just a lot of data. To minimize this data and to control it, we'll control the verbosity of these logs. We'll tell Kubernetes that we care only about certain things and to log only those certain things. And we'll do that by telling it what to log and when to log it. And we'll do this by, no surprises, using YAML. Let's see how to get this running. How to tell Kubernetes what we care about. We'll use something called as an audit policy for it. It's a YAML file. It has the API version of audit.k8s.io/v1, a kind of policy. It has rules which tell Kubernetes what we care about and what things we want to log and when we want to log it. So you see something called stages here, and we briefly saw that in the whole JSON blob thingy as well. So let's see what it is and try to understand it better. So again, API server request comes. So the life cycle of the request through the API server and when the response gets created, depending on the time in that whole life cycle, you can decide when you want to log things. So the first stage is called request received. It's when the audit handler in the API server receives the request, but the response is not generated yet. So it's just the request received. The request has been received. The second stage is response started. The response headers are sent out, but the response body is not sent out yet. This stage only occurs for long-running requests like watch. The third stage is response complete. It means that the response body is also sent out. And the fourth stage is panic, whenever a panic is generated in this whole process. Now this might be a lot to take in. Let's make this easy and let's visualize it. So you have your API server and the request. Once the request is received into the API server, you get the request received stage. Then the response is generated. If there's a panic in this process, you get the panic stage. If there's no panic and it's a long-running request, so the response headers are sent out, like watch maybe, and then the response body is sent out, so the response is complete, and then you finally have the response. So we have these four stages: request received, response started, response complete, and panic. And this is very important to understand because you will be using these terms in our rules when we tell Kubernetes that these are the things we care about and please log only these things. Moving on, so I talked about when to log. So this was in the life cycle of the request. We'll define certain stages. Now we can also tell Kubernetes what things we want to log, what resources we want to log. So we can define the group version, resource, and verbs. So we can tell Kubernetes that we only care about secret deletion events. So we'll say the group will be core, so we'll leave it blank. Resources are secrets. We can also put out the verb that we want only deletion events because that's what we care about. Now we see some other new term here which says level. Let's look into that. Levels tell Kubernetes again how much portion of the resource or what's going on that we want to log. So none means don't log these requests at all. Metadata means only log the request metadata. Request means metadata and the request body. And request response means metadata, request body, and response body. So we saw a lot of things right now, and if you're just starting out with Kubernetes, this might look a little overwhelming. this is also overwhelming for anyone who actually knows Kubernetes and has been involved for quite a long time. It's also harder to figure out hey, I want to log only these resources, because there are system calls happening as well. It's not just the calls that you're making. You just do one kubectl get pod. You just run one command, but then the system is running 1,000 other commands. So how do we write policies that make it easier for us to get logs? So let's look at some recommendations. First recommendation, that's a very important one, is that if you have sensitive resources like secrets, config maps, or token reviews, only log at the metadata level, because if you don't do that, you'll also get your secret sensitive information in the logs, and that kind of destroys the whole point. Don't log read-only URLs or non-resource URLs, because you probably don't care about it, and it's a huge high volume. It just blows up your logs. The general idea is log at least the metadata level for most of the resources, and log at the request response level for critical resources like pods that you care about maybe. So in this example, we have two rules. One is a level for request response, and the other is for metadata. When you write two rules, let's see what happens. So rules are evaluated in the top-down order, which means that the top rule is considered first. So the first rule is request response, and for pods. So pods are generally critical resources, so you want to log them at the request response level to know if something goes wrong, what actually happened. Sub-resources like status and log are very high volume and generate lots of logs, so you can just log them at the metadata level. There can be way more ways you can define things, so lots of them can be found at this link in the Kubernetes source code. Yeah, you can check it out here. So let's find out so you realize that, okay, we know what audit logs are now. We know that if you want audit logs, we'll have to tell Kubernetes what things to log at, so we'll have to write audit policies for it. And we went through some recommendations about how to write audit policies. Now let's see, where do these logs actually go? Where is it stored? What happens with it? So the place where these logs actually go is called backend, and there are two types of backend, a log backend and a webhook backend. The log backend writes these logs to a disk, and the webhook backend sends it to an external API. For the log backend, you will give the audit log path flag to the API server to denote where the file path to where these logs should be stored. And the audit webhook config file flag for the API server denotes the webhook configuration for where these logs should go. And the audit policy file flag is used for both backends, and it will be used to basically give out the policy file, the whole rules that we just learned about. So let's go a little deeper. We figured out that these logs go to a backend. Now we can also give more details, or we can also tell Kubernetes how we want all of this information to go. That's defined by batching. So do we want it to go in batches, or do we want them to go individually, or do we want something else? So the batch method is, as the name suggests, the logs or the events go in batches. The blocking method, it sends individual events, and the blocking strict method, if there is a failure at the request receive stage. So there's a failure at the first stage, that whenever the request is received at the API server, it leads to the failure of the whole call. You can specify the batching method using the audit webhook mode flag on the API server and the audit log mode at the API server. So it would be audit webhook mode equals batch, or blocking strict. And for the webhook mode, batch method is the default method unless specified. So we saw that all these flags are sent to the API, are applied whenever you're starting the API server. So whenever you want to update a policy, let's say you made a typo, or you want to change something, or you screwed up indentation for YAML, which never happens, then you need to restart the API server each time. and that is absolutely no fun at all. So what if, to update the audit policy, we could just update a Kubernetes resource? We could just do a kubectl apply-f. That would be helpful. So that's where dynamic audit configuration feature comes in. It is still an alpha feature, so you need to supply the feature gates and the runtime config flags to the API server, and the audit dynamic configuration flag as well. Once this feature goes GA, you just need to supply the first flag. So this feature is still alpha. There's a lot of work going into it. We'll see how you can, what this work is and how you can get involved as well. So this is what that Kubernetes resource looks like. The API version is audit registration.kh.io. It's still alpha, and the kind is audit sync, as in like a kitchen sink, not the SYNC sync. The spec includes the policy, that is the rules that we talked about. It also includes the webhook configuration where these logs should be sent to. So if you want to update the policy, it's as simple as updating the spec and applying the config, and the policy is going to get updated. Two things to keep in mind when we are using this feature, because this feature looks dead simple and, well, sort of simple. So it feels like you want to use as many of, create as many of these resources as possible. But you need to keep in mind the security and the performance considerations in this case. So regarding security, write access to this feature basically grants read access to all cluster data. So you want to restrict this to the cluster admin level privilege. We also found that using too many audit things has performance implications for the API server. So you want to make sure not to use too many audit things. Using nominal number is okay. There is still being performance testing done on this, and the benchmarks should be published before the feature moves to beta or we make any more changes to the feature. And that brings me to the KEP. So KEP in Kubernetes is a Kubernetes enhancement proposal. It's basically a design proposal for any feature that goes into Kubernetes that talks about the motivation behind the feature and the whys and the hows and whatever the design is being proposed in the feature. So this KEP is related to the dynamic audit policy. We eventually want to make it beta and then finally GA, but right now it's alpha. We realize that we can make this whole process of writing a policy way easier, because we saw that we need to know what's going on inside the API server. We learned about 4 stages and 4 levels, and it's just all too complicated, and a random user of Kubernetes should not need to know about so many internals. So to make all of that easy, we have a KEP. Check it out if this sounds interesting to you. We definitely need more volunteers to help out with this. It's been alpha for quite a while, so we definitely want to make it GA. Even after this KEP, it's still going to remain in alpha because we're changing lots of things. So this is a very good place to get involved early in the cycle. You can get more influence into the decisions that goes on into this feature as well. So the link is the link to the pull request that adds this KEP. And if you want to get involved, or if you have feedback or questions, you can check out the SIG-Auth Slack channel on the Kubernetes Slack. This was too much information and there's too much logs. I just want to give you a very, very quick, it's not a demo per se, but a quick intro on how these audit logs look like. So, okay, let me make this, oops, bigger. Okay, so I will do a Minikube start. I've already done this before, so I'm not going to run it and wait for it to complete. Again, if anyone else is interested in Minikube, find Rohit. He's a Minikube maintainer, and you can ask him any questions about Minikube and how to get involved. If I want to find out how many logs we have, I'm just going to run how many number of lines we have in these audit logs. It's 14,214, and I started this cluster when the keynotes got started. So it's logged 14,000 lines in such a short amount of time. So that's a lot of logs. And to give a brief more information, this is how it looks like. There's just way too much information. And to analyze it manually is almost impossible. So to make all of this easier and to understand how all of this comes about and how to actually use it, we're going to be talking a little bit about log collector patterns. I'm not going to go too deep into this. It's a 101 talk, and each of these examples can be its own talk. So we'll look into brief about how you can collect these logs, how you can make sense out of it, and all of these examples have detailed details about how to set it up on the Kubernetes website itself. So the first thing we're going to be talking about is using an audit log file and FluentD. FluentD is a CNCF project, which is basically a data collection software. So you can use a log file, you can send it to FluentD, and FluentD will process it, and you can add filters to it. You can basically get something like audit events per namespace that can help you out to further filter out however you want, however you want the audit logs to look like, or however you want to filter it. The second example is using Logstash. So Logstash is a server-side data processing platform. So you can use webhook files, so the webhook backend for audit logs, send it to Logstash, and you can get something like audit logs per user per file. You can also write policies which can filter out logs per user. So if you want logs for actions only created by a particular user, because I don't know, you think something fishy might happen whenever a particular user does something, you can use this. Another very popular design pattern is to use a webhook file plus Falco. Falco is a project for automatic detection of suspicious behavior for cloud native platforms. So you can use a webhook file and then send it to Falco, to the Kubernetes audit endpoint in Falco, and it will automatically detect suspicious behavior and give out results. So it does all of the work for you. So we learned about audit logs, and I talk about this in the beginning, what are the advantages, and then go into it. But I wanted to make you all understand what audit logs are and to get a brief overview of what it is before looking into how it's helpful. So the first thing that not many people use it for is understanding Kubernetes internal. So it's user calls and system calls as well. So if you analyze the calls, it can tell you about what's going on behind the scenes and how Kubernetes works internally. It can help you detect misconfigurations. As we saw earlier in the example, it can tell you who updated your secret with that strange suspicious value. It can help you answer questions like who deleted this secret or who deleted this resource. You can also analyze calls and figure out which HTTP status error code you're getting a lot. So for example, if you're getting lots of 403s, it probably means you have misconfigured RBAC. It can help you identify performance issues and answer questions like which app is generating the most number of calls. So we saw a lot of things here today. We saw what audit logs are. We saw that we need to write audit policies and define rules to tell Kubernetes what logs we want. We saw some recommendations for writing these. We saw that we need to send these logs to particular backends. We saw how we can send these logs to different batching methods, and then we came across this awesome feature called dynamic audit configuration, which helps you define all of this in a simple Kubernetes resource. It's alpha. We want help. Please get involved. You don't need to know anything about Kubernetes internals or how everything works, but if you want to get involved, come find me. Come find for Minikube, again, I'm going to iterate, come find Rohit. There are lots of upstream contributors in this, room. Find any of us, and we can help you get started. So thank you, and yeah, hope you're all having a wonderful conference. Do we have time for a Q&A session? No, we don't. So if you have any questions, please find me after the talk. Thank you.